All right, let's talk about dragon fruit. It seems like overnight this thing went from a strange-looking curiosity to being in supermarkets everywhere. But what does it take to get a perfect one from the farm to your fruit bowl? Well, it turns out there's a really complex, high-stakes decision being made, and a new kind of AI is stepping in to get it right almost every single time.
Okay, so take a look at these three. You've got one that's raw, one that's ripe, and one that's already defective. To most of us, the differences might seem pretty subtle, right? But for a farmer, one wrong call, shipping a fruit that isn't quite ready or has a tiny hidden spot of rot that can cause an entire shipment to get rejected. That's a catastrophic financial loss, all from one little mistake.
And that right there is what we're calling the dragon fruit dilemma. This isn't just about making sure you get a tasty piece of fruit. This is about a massive global industry where there is practically no room for error.
And just to give you an idea of the stakes here, you have to understand the scale we're talking about. Dragon fruit went from being a cool tropical oddity to a huge global business. In Vietnam alone, they're harvesting over 1 million metric tons every year. That's an enormous economic engine that supports thousands upon thousands of small farms.
But here's the real kicker, and it comes down to biology. Dragon fruit is what's called non-climateric. Now that's just a fancy way of saying that unlike a banana or an avocado, it completely stops ripening the second you pick it. It's not going to get any sweeter or better sitting on a truck or a supermarket shelf. So that decision made in the field, it's final. There is literally zero room for error.
So you can feel the pressure, right? And you'd think, well, technology should be the answer. But the first attempts with AI ran into a really big problem, the black box problem. It turns out that being fast isn't all that helpful if you have no idea what the tech is actually thinking.
Let's start with how it's done now. You've got human inspectors making these split-second calls, one fruit after another. The researchers put it perfectly. After a few hours, you get tired. Mistakes happen, and everyone's got a slightly different idea of what perfect looks like. That kind of inconsistency just doesn't fly in the export market.
So naturally, they brought in AI, and the early models were lightning fast at sorting, which was a great first step. But they had this one huge fundamental flaw. They were complete black boxes. They could tell you, yep, that one's ripe, or nope, that one's defective, but they could never ever tell you why.
And this is the whole issue right here. A black box AI is a system where the logic is a total mystery. Think about it. If you're a farmer and the AI says a fruit is bad, you need to know why. Did it see rot or was it just a shadow? If you don't know, you can't trust the system. It's just a magic box spitting out commands you can't question.
And this is where the story gets really clever. The researchers realized they didn't just need a more accurate AI, they needed a more transparent one. So let's look at how they built a genuinely smarter way for a machine to see.
Okay, so this new hybrid model has this awesome three-step approach. First, it cleans its own data. It gives every single image a unique digital fingerprint, which it uses to find and get rid of any duplicates. This stops something called data rot, which is basically when an AI gets confused by being trained on the same bad data over and over. Second, it uses a new tech called a vision transformer that looks at the entire fruit at once. It sees the whole picture, not just little groups of pixels. And finally, a different part of the system makes the final call in a way that's totally clear and easy to understand.
And this chart just breaks it down perfectly. The old AI looked at tiny pieces, got confused by messy data, and kept its thinking a total secret. This new system, it sees the whole image. It makes sure the data is clean, and, this is the most important part, it's designed from the ground up to show you its work.
So that all sounds great in theory, but does it actually work? Well, the researchers put this new system in a head-to-head competition with the older models, and the results were pretty amazing.
Just look at this chart. You can see how 4 different AI models performed. Now, the other ones did pretty well. They're established technologies for a reason. But the new hybrid model, this VIT-SVM, just consistently came out on top. It had the highest accuracy of the whole group.
And here is the number, 99.84% accuracy. Look, in a business like agriculture, where the margins are razor thin, that tiny fraction of a percentage point, that's the difference between making a profit and losing your shirt. It's just an incredible level of precision.
But let's not forget the black box problem. That incredible score is fantastic, but it's not enough. For this tool to actually be trusted and used by farmers and exporters, the AI had to crack open that box and show everyone exactly how it was reaching its conclusions.
And this is where something called explainable AI, or XAI, comes into play.
You can think of it as a way to see through the AI's eyes. It basically creates a heat map on top of the image that shows you the exact spots the algorithm was paying attention to when it made its final decision. And here it is in action. It's so cool. On the left, you've got a perfectly ripe dragon fruit. On the right, that's the AI's heat map. See how it's glowing? It's focusing entirely on that deep, rich magenta color of the skin. It's not looking at the leaves or the table. It knows the color of the skin is the key indicator for a ripe fruit.
Now check this out on a defective fruit. The heat map immediately lights up right over the discolored, rotting parts. This is that crucial proof we were talking about. It shows the AI isn't just guessing. It's learned the real visual signs of what makes a fruit healthy or sick. This is how you build trust in a system.
That, of course, no system is 100% perfect. And what I really respect is that the researchers were totally open about the few times it failed. In this case, the AI called a healthy fruit defective. And the heat map shows us exactly why. It honed in on the browning tips of the little green leaves on the fruit. It's a natural drying process, but it looks a little bit like rot, and it was enough to fool the algorithm. Being this transparent is how you make the system even better down the line.
So what's next for this incredible technology? I mean, the potential applications go way, way beyond just this one fruit. We're really looking at a glimpse into the future of farming.
So the next steps are pretty clear. First, they want to get this out of the lab and into the real world by deploying it on mobile phones, so farmers can use it right there in the field. After that, they can train this same model to grade other important fruits, like mangoes and guavas. And the really big dream? Integrating this system into fully automated sorting lines that can process fruit in real time on an industrial scale.
And that really leaves us with a pretty fascinating question to think about, doesn't it? Because this was never just about dragon fruit. This was about proving you could build an AI that is not only incredibly accurate, but also completely transparent and trustworthy. So if we can teach a machine to master a subjective, expert human skill like this, what's next? What other complex human judgments are on the verge of being understood and maybe even perfected by a machine?